Good morning, 7th graders. How are you today? It's Miss Trenum. I didn't bring food today, but that's okay. I had chili Crispitos last week for breakfast. I actually had chili Crispitos yesterday for lunch. They were so good. Today we're going to talk about MAD. So if you remember last week, I left you with the little teaser that said I was going to teach you what the acronym MAD meant. Well, last week we were still on statistics, and we talked about random sampling and how we could figure out how many people in your school actually like chili Crispitos. Well, today we're going to continue on statistics, and we're going to talk about mean and MAD. So we're going to be looking today at some representation, some visual representation, some actual graphs and charts, and we're going to compare some data sets to see if we can answer a few questions in our statistics lessons today. That's a hard word to say. But first we need to review a little bit of vocabulary from our previous classes. So let's look at three words, and we're going to remember the vocabulary, and we're going to be using these today as we go through. So first we're going to look at the mean. If you remember back from 6th grade what the mean means, it's the average of the numbers, okay? It's just the average. It's where you add up all the numbers in your data set and then you divide it by the total. That is the mean. So then we're going to be looking at the range, which is the difference between the highest data point and the lowest data point. This is a new word today, or a new vocabulary. It's the mean absolute deviation. I know that's a really big word and it's got a lot of words mixed into it, but don't get confused yet. Hopefully by the end of this lesson you'll understand what mean absolute deviation means, because it is the average distance of each data point from the mean. Don't let that overwhelm you. We're going to get to it, okay? But just remember, it's the average distance of each data point from the mean. So let's get started. 2 of our teams at school have been in a T-shirt selling contest. The Jumpsters, which is our basketball team, has 10 members on their team. The Sliders, which is our baseball team, also has 10 members. Each team is declaring themselves the winner of the T-shirt contest. So it is up to us to determine who the actual winner is. So let's look at the T-shirt sales data, okay? So we need to try to determine a winner. So the Jumpsters, if you look right over there, Jan and Al and Max sold 2 T-shirts each. And then Shayna and Lisa sold 3. Barry and Linda sold 7. Sam, Bud, and Chelsea sold 8. So we have our numbers for the Jumpsters. Now let's look at the Sliders. Ashley sold 2. Inslee and Odie sold 4 T-shirts. Danielle, Kelly, Paul, and Florence all sold 5 T-shirts each. Lucy and Maggie sold 6, and Ronnie sold 8. Well, if you look at the T-shirts sold, that looks pretty, maybe consistent. But in order to determine a winner, we need to find the average T-shirt sales. So let's look at the average of both of these. If we add up all of the T-shirts of the Jumpsters, and we see that the Jumpsters sold 50 T-shirts. If we divide that by the number of members, we get 5 T-shirts each. That means they had an average or a mean of 5. So the Jumpsters have an average or mean of 5. So now let's look at the Sliders. If we add up all of the Sliders T-shirts that they sold, they also sold 50. And they have 10 team members. And if we divide 50 by 10, they also have a mean or an average of 5. I don't think that's going to let us determine a winner. So we can't use the mean to determine a winner, so let's move to the range. Let's check the range. So if we look at the range of the Jumpsters, we take the highest data point and we subtract the lowest data point. So Chelsea sold 8 T-shirts, Jan sold 2 t-shirts, and if we subtract 8 minus 2, that gives us a range of 6. Okay, so the jumpsters have a range of 6. So let's look at the sliders. If we look at the sliders range, Ronnie sold 8 t-shirts and Ashley sold 2 t-shirts. So if we do the same mathematics and subtract 8 minus 2, we get 6. So the jumpsters and the sliders actually have the same mean and the same range. So how can we determine a winner? They look pretty equal. Let's just call it a tie. Can we just say both teams win? I don't think that's going to happen because I think one of them wants to be declared the winner. So we're going to have to take another step in our statistical data and see if we can actually find a winner. So how do you feel like we should be able to choose a winner? That's where our MAD comes in. So let's actually graph our t-shirt sales, and so we can see kind of the difference between the two teams. So if we look and if we graph the jumpsters on a dot plot, we see that a lot of it's concentrated on one side of the mean and a lot of it's concentrated on the other side of the mean. Okay? If we graph the sliders, we look and we can see that most of the sliders t-shirt sales are concentrated right somewhere around the mean. Now remember, we have the same mean or average for both teams and the same range for both teams. So we're going to have to choose a different method in order to calculate a winner. Which distribution to you looks more spread out? We just talked about that a minute ago. If you look at the jumpsters and the sliders, the jumpsters data points are a little bit further away from the mean, but the sliders data points are a little closer to the mean. So which one looks more spread out? Of course, the jumpsters looks more spread out. So in order to try and calculate a winner, we need to use the method of finding the mean deviation. And this is going to be a really kind of tough definition, but stay with me because we can handle it. The mean deviation is the average distance of the data values from the mean. Don't leave me yet. I promise I can help you. It's the average distance of the data values from the mean. So let's see if we can calculate the actual mean deviation of each team and see if that'll actually help us declare a winner. So let's look and see if we can find out what the difference between the mean and each data point is. I'm going to read the question one more time to see if you can help find an answer. What can we do to find the difference between the mean and each data point? There's a key word in that sentence. Are we going to multiply, subtract, divide, or add? We are going to subtract because we're going to subtract the mean from the value of each data point. And I know that sounds really confusing, but on the next part of this lesson, I think you'll understand what we're talking about. So let's take the jumpsters, okay? So what will happen when we add the deviations together? So let's look over here. First, let's actually find the deviations, okay? So X represents the t-shirt sales. And then X minus the mean represents the deviation. So let's calculate that. On our first entry, the first data point is 2. That means Jan, I think she was the first one, sold 2 t-shirts. So if we take 2 and subtract the mean, 2 minus 5 gives you -3. So we're going to do that for every single teammate that sold t-shirts. So if you see, everyone that sold 2 t-shirts, their deviation from the mean is -3. And then every person that sold 3 t-shirts, that's 3 minus 5, gives you -2. So their mean deviation is -2. And then the 2 teammates who sold 7 t-shirts, 7 minus 5 gives you 2. So those two answers are positive 2. And then the last three who sold 8, so 8 minus 5, their deviation from the mean is 3. So what will happen if we add up all these deviations together? So let's look. We plotted the deviation from the mean on this dot plot. Do you recognize anything? Do you see anything that looks kind of funny? Exactly. There's 3 negative 3s and 3 positive 3s. There's 2 negative 2s and there's 2 positive 2s. What do you think is going to happen when we add all of those deviations together? You're exactly right. They cancel out. If you add up all of the deviations, you get negative 13 plus 13 gives you 0. Well, that does us no good because we still can't declare a winner of the T-shirt sale contest. So we are going to have to use the absolute value of the deviation from the mean. The absolute value. Now you know what the A in MAD means. The A stands for absolute. MAD stands for mean absolute deviation. So we're going to find the absolute value of the distance away from the mean. Stay with me. I know, seems really complicated, but it's not. It's going to get easier. So let's check, how do we actually find the mean absolute deviation? Here are our instructions. We find the absolute deviation for each data point, and then we find the mean or the average of those data points. So let's take the jumpsters first. Now remember, a few slides back, we actually found the deviation from the mean, but this time we're going to find the absolute value of each of those deviations. So if you look back to where we started, 2 minus 5 was negative 3. We're going to take the absolute value of negative 3. Now remember, the absolute value of any number is its distance away from 0. So let's review absolute value. If we have negative 2 is 2 spaces away from 0. So the absolute value of negative 2 is 2. If you have 2 is 2 spaces away from 0. So the absolute value of 2 is 2. So every time you're finding the absolute value, it's going to be a positive number because it's just the distance that that number is away from 0. So let's go back to our jumpsters. If we look at all of our deviations that we calculated a little while in a few slides back, and we go back and we find the absolute value, we have 2 minus 5, which is negative 3. The absolute value of negative 3 is 3. So we did that for all of the teammates that sold 2 T-shirts. So what this represents, the 3, is that this tells us that this student or these students sold 3 less T-shirts than the average, our negative 3s. They sold 3 less T-shirts than the average student. Well, if we come down here to the who sold 3 T-shirts, so 3 minus 5 is negative 2. The absolute value of negative 2 is 2. This tells us that those students sold 2 less T-shirts than the average. Let's move on to the 7s. 7 minus 5 is 2. The absolute value of 2 is 2. This tells us that this student sold 2 more T-shirts than the average student. And the same when we get to 3. 8 minus 5 is 3. The absolute value of 3 is 3. It lets us know that those students sold 3 more T-shirts than the average student. Now let's add up all of our absolute deviations, and we come up with 26. So 26 divided by 10 is 2.6. So our mean absolute deviation, or our MAD, for the jumpsters is 2.6. Now we need to move to the sliders. Okay, so if we do the same thing and we calculate all of our deviations, 2 minus 5, negative 3, absolute value is 3. That means that student sold 3 less T-shirts than the average student. 4 minus 5 is negative 1. The absolute value of negative 1 is 1. That lets us know that that student sold 1 less T-shirt than the average. The 4 students who sold 5 T-shirts, 5 minus 5 gives us 0. The absolute value of 0 is 0. This tells us that those students sold the same amount as the average. And then we move on down to the bottom, which is 6 and 8, and we have some absolute values of 1 and 3. So when we add up all of the absolute deviations, we have 10. And 10 divided by 10 gives us 1. So the mean absolute deviation for the sliders is 1. Well, now we need to compare the two together. So let's compare the MADs of both the jumpsters and the sliders. The jumpsters has a MAD of 2.6. The sliders have a MAD of 1. Well, how does that relate to how do we use this data to declare a winner? Now remember, they both have the same mean, which is 5. They both have the same range, which is 6. But the jumpsters have a MAD of 2.6, and the sliders have a MAD of 1. So let's see if we can distribute the data and see if we can get generalize some information about this. So I put the graphs back up here. So look at the jumpsters on the top. Their mean is 5. Their MAD is 2.6. And we have the sliders right down here. Their mean is 5 and their MAD is 1. Looking at the graph and thinking back to what we talked about earlier in our lesson, let's see if we can come up with some generalizations here from our answers. The lower the MAD, the less consistent the distribution is. Well, let's go see. The sliders have a 1 as their MAD. What do you see about the distribution of their data? Is it further apart or is it closer together? The lower the MAD, the less consistent. I don't think that's right because I think it's more consistent. I think they're closer together. So I don't think this is the right answer. So let's look at the second one. The higher the MAD, the less consistent. Well, let's look. The jumpsters have a MAD of 2.6 and their data points are spread out. I think that's a good one. The higher the MAD, the less consistent the distribution is. Well, let's see if there's more than one answer. So let's look at the third one. The lower the MAD, the more consistent. I think we saw that a minute ago, right? If we look back over here to the sliders, we see that their data points are close together. So they're more consistent and concentrated around the mean. So I think that's a good answer too. The lower the MAD, the more consistent the distribution. Well, let's check out the last one just to be sure. The MAD doesn't tell us anything about the distribution. I don't think so. We've already shown that. We've already shown that the MAD does have something to do with the distribution. So let's look one more time at our data. The teams have done a great job. For the jumpsters, their mean was 5, their MAD was 2.6, and their data was not as consistent, correct? On the sliders, the mean was 5, and their MAD was 1, and their data points were all really close to the mean. Well, what does that mean? The lower the MAD, the more consistent the distribution will be. Let's look. The lower the MAD, the closer the data points are going to be to the mean. The higher the MAD, the less consistent the data points will be. The lower the MAD, the less consistent. So I feel at this time we can make our ruling. Do you think we can declare a winner? Both teams have done a great job, but the Jumpsters t-shirt sales were not as consistent because their MAD was higher. So do you think you can come up with the winner between looking at the Jumpsters and the Sliders? Actually, we did. The Sliders win. Their data was more consistent because their MAD was lower and it was more concentrated around the mean. So we can declare that the Sliders win the t-shirt contest because they had more average sales than the Jumpsters. I'm so glad that you came today, and I'm so glad you tuned in. We have a few more weeks of school. I know you're excited. I'm excited for next week. So here's what we're going to be studying about next week. A game at a school carnival has 3 different spinners. The spinners are shown here. Which spinner is more likely to land on A? So next week we are going to be talking about probability. So I need you to think about this. Which spinner do you think will land on A? I hope you have a great week, and I'll see you next Tuesday. Ms. Trenum signing off.